Hello and welcome back to this channel. And today in this video is going to be very important, and in this video we are going to discuss about the 27th Jan first shift, whatever is the paper of JEE Main. That paper I am going to discuss in detail. I will discuss all the things, not only that this will be the answer or that will be the answer. No, not like that. I will discuss this with explanation, that probably like if you are going, suppose if your exam is going good, then it's well enough, no problem. But suppose if you are preparing for phase 2, like the next exam, then also it will help you immensely. Okay, so you see how I am solving, how I am tackling the question, how I am approaching the questions. Okay, and in total I got 31st question, total 31 questions I got, and obviously that total exam was of 30 questions, right? So maybe like I got one question extra because I have asked so many of my students and they have given me the questions. Obviously it's a memory based paper, and these questions are in the exam. Almost all of the questions are in the exam. Maybe the wordings and some things are changed, but these questions are this in the exam, these topics are in the exam, that's for sure. Okay, so with that I am going to start, and you see how I am approaching this question. So the first question is, which of the following has maximum magnetic moment? Sir, magnetic moment formula is mu equal to root over n into n plus 2 Bohr magneton, where n is the number of unpaired electrons. So this type of question you should not take more than 30 seconds. More than 30 seconds. How to do it, sir? Sir, mu is equal to root over n into n plus 2. N is the number of unpaired electron. Set 3d3, you put it 1 2 3 4 5 1 2 3, that means set 3 unpaired electron. But said if I put 3d6 1 2 3 4 5 then 6, that means that 4 unpaired electron. And if you put 3d7, obviously you got it 1 2 3 4 5 6 7, that means that 3 unpaired electron. Please listen carefully. Maximum number of maximum magnetic moment, it doesn't mean that you should have more number of electron. No, you should have more number of unpaired electron. You should have more number of unpaired electron. So put the electrons in the orbitals, put the electrons in the orbital and see where you are getting most number of, very important, most number of unpaired electron, and you got it in 2. So here 2 will be your answer. 2 will be your correct answer. This is a very easy question. Okay, now let's jump to the next question. In the next question, what is given? It is given that methane, mass of methane required to produce 22 gram of CO2 upon combustion. So sir, methane एक हाइड्रोकार्बन, मीथेन एक हाइड्रोकार्बन हो गया. Sir, हाइड्रोकार्बन means I can write it CXHY plus oxygen. From here I will get CO2 plus H2O. I have solved this question from class 11 also. X plus Y by 4. From here X CO2, Y by 2 H2O. And sir, methane means it will be CH4. CH4 means H, X equal to 1, Y equal to 4. Sir, if I compare this with CXHY, then X equal to 1 and Y equal to 4 put here, then sir I will get 1 plus 1, that means 2 moles of oxygen I am getting, 2 moles of oxygen. But this is not required here. What you required is that X value. So if it is C1H4, X is equal to 1, so you will get 1 mole of CO2, 1 mole of CO2. That means that 1 mole of CO2 means what is it at molecular mass? You calculate carbon is 12 plus oxygen is 32, so 44 gram. And methane also calculate the molecular mass. Carbon is 12 plus oxygen, hydrogen is 4, that means 16. So can I write? So the equation is CH4 plus O2, 2O2. From here you will get CO2 plus 2H2O. I am having no problem with these things. I am only concerned with CH4 and CO2. So can I write 44 gram oxygen we can get from 16 gram CH4. How much oxygen you need? 22 grams. So sir, 22 gram will be 16 into 12 by 44. Just do unitary method and 8 will be your answer. 8 will be your answer. You have to write 8 here. All are happy, the examiner will be happy, and you will get the full marks. So this is from combustion reaction. Conversion reaction, that is in detail we have done in class 12 board also, right? Now go to the next topic. What is given? Boron has very high melting point. This is actually from P block. This is actually from P block, general introduction to P block. Okay, the whole chapter is not in your syllabus right now, but some parts are there. So general introduction of P block, from there boron is actually in group 13. I told you from boron you have to get like the general electronic configuration of boron, aluminium, all those. You have to learn about inert pair effect. You have to know about inert pair effect. You have to know about B2H6, the banana bond, all these things that you have to know. So from here you got a question that boron has very high melting point. Yes, that's true. Boron is having a very high melting point and the value is 2453 Kelvin. But the question is why? Because boron, as it is a very small in size and it can make crystalline structure. It can make crystalline structure. What is the crystalline lattice as it is given here? Okay, crystalline lattice. And as I told you that for boron the most important or most famous structure is called or alpha rhombohedral, right? Alpha rhombohedral, alpha rhombohedral is the most important structure of boron. This is the crystalline structure, and as it is a crystal lattice, as it is a crystalline solid, so it is having a high melting point. Obviously crystalline solid or crystalline lattice, they are having usually high melting point. So here assertion is also true and reason is also true. Both are true here. Okay, so now go to the next question. Oh my god, this is probably the easiest question, and I have told you a trick also. Sir, what is the trick you told me? The trick I told you, calculate the number of electron. Calculate the total number of electron. And from there we can directly do bond order. And I also told you that yes, don't always use the trick, because like I am against tricks. Okay, but here this trick is quite logical. So that's why we can use this trick. What is the thing, sir? Total number of electron you calculate. Sir, how to calculate? You take CO. Sir, CO means carbon is having 6 electron, oxygen is having 8 electrons, so total electron is 14. Sir, NO plus means nitrogen is having 7 electron, oxygen is having 8 electron, and as it is a positive charge, that means 1 electron less, so total use is 15 minus 1, that means sir it is also 14 electron. And I know, sir, what you are going to tell next, that sir if it is 14 electron, bond order is always 3. You don't have to do any other calculation. If number of electron is 14, bond order is always 3. But 3 is not your answer. Here you have to do the sum. So do the summation and you will get 6 as your answer. So 6 will be your answer here. It's a very easy question. Then go to the next question. Oh my god, this is another easy question. How many electrons, of the following have +4 oxidation state of the central atom? Okay, sir. BaSO4 means Ba2 plus and SO4 2 minus. Sir, SO4 2 minus, I don't know about the central atom. Okay, which atom you have to count? You take that as X. So sir, sulfur I am taking as X plus 4 oxygen, and each oxygen is having -2 oxidation state, equal to total oxidation state is -2. So X minus 6 equal to -2, X equal to +4. Yes sir, for sulfur I got +4. So definitely BaSO4 will be sorry, I have done a mistake here. It will be it will be plus -8. It will be -8, sorry. Yeah, it will be -8 equal to -2. So X equal to -2 plus 8. Sir, X equal to +6. sir plus 6, but they are asking for plus 4. Sir, BaSO4 is not your answer. Okay, no problem. Go to the next one. Go to SOCl2, take sulfur as X, oxygen as -2, 2 chlorine, and each chlorine is -1, and overall as it is a neutral, so 0. So X -2 equal to 0, X equal to plus 4. Yes sir, I got one of them as plus 4. Okay sir, I got it. Now what you are trying to do, SF4 also you take sulfur as 4, plus fluorine is 4, and each fluorine is -1 equal to 0, X -4 equal to 0, X equal to plus 4 sir. This is also my answer. And H2SO3, if you do take the sulfur as X, hydrogen 2 into plus 1, right? Hydrogen is H plus, and oxygen 3 into -2 equal to 0. So 2 plus X -4, 6 equal to 0, X -4 equal to 0, X equal to sir plus 4. Sir, this is also possible. Okay, for the next two thing I have to go and I have to take another slide. Okay, so what is given, let me just check. H2S2O7 and SO3. H2S2O7, SO3. Okay sir, for 2 hydrogen, 2 into plus 1, plus sulfur 2 into, I will take that as X, plus oxygen 7 into -2 equal to 0. So 2 plus 2X minus 14 equal to 0. 2X equal to 12, X equal to plus 6. That will not be my answer. Here it will be X plus 3 into -2 equal to 0, X minus 6 equal to 0, X equal to plus 6. That will also be not my answer. So sir, I am getting answer as SOCl2, SF4 and H2SO3. That means 3 will be my answer. 3 will be my answer here. Okay, now go to the next question. What is the question? In this question, yes, there are some confusion in this question. So my students are also facing some difficulties in this question. So there is nothing to be difficult here. You see PbCrO4 plus NaOH if it is given in hot excess. From here actually you are getting two product. From here you are getting actually two product. You see, you think like this way. PbCr4 is what? Pb2 plus CrO4 2 minus, Pb2 plus and CrO4 2 minus. Now this Pb2 plus, if you want to replace with sodium, sodium is +1 charge, but +1 charge, with the +1 charge, if you want to replace this 2 plus charge, obviously sodium, how much you need? You need 2 sodium. So that means you will get Na2CrO4. Got it? This Pb will be replaced by 2 sodium. Now this is the molecule we use, we are interested. But here the question is, here one byproduct also you will get. What byproduct sir? Sir, this Pb will come with this OH and it will actually make a complex PbOH whole for 2 minus, PbOH whole for 2 minus. And to satisfy the charge, obviously you need Na2PbOH whole 4, Na2PbOH whole 4. So this is the thing. That means that you are saying that 2Na plus PbOH whole 4 2 minus. Yes, so this is the thing. Now they have asked the question regarding this thing. That's it. They have asked the question regarding this. Okay sir, I got it, that coordination number is 4. Coordination number is 4 and it is dianionic. That's it. Its coordination number is 4 and it is dianionic. That means option number A will be your correct answer. Option number A will be your correct answer. It's so easy, right? Now this question is from a conceptual thing. If you understand the concept, like from this solution chapter, what like usually students do, they usually do the numerical problems. But this is from concept. What is the concept they are asking? They are asking for negative deviation from Raoult's law. So negative deviation means, suppose what? Suppose you are having a solution and suppose you are having a B solution. Now this is having a vapor pressure, obviously P0 A. This is having a vapor pressure, obviously P0 B, right? This is obviously having, and now what you have done, you have mixed them together. Please listen carefully, you will understand. It's so easy. Now you mix them together, then you make it A plus B, a solution you have made. Okay, now previously it was pure solvent, and this was also a pure solvent. Okay, pure solvent and pure solvent, but now you have made a solution. Now you are expecting that here P will be P naught A plus P naught B, but what you are expecting this, it is expected, but what is happening that P value is lesser than P naught A plus P naught B. This is the experimental value. This is the experimental value. So let me just go to the next slide, that will be easier for us to understand. So that means if you put a graph, and I hope you know this graph, that suppose from here you will get this kind of graph, from here you are getting this kind of graph, and you are joining this graph, you know, right? This graph, this is your vapor pressure, this is your vapor pressure, and this is your mole fraction of A and B. Now you are expecting the graph to be like this, but it is actually showing negative deviation. It is actually showing negative, that means less value. But why you are getting the less vapor pressure? Why you are getting? Obviously in A there was a AA interaction, sir. Obviously in B you are having BB interaction, and A plus B when you have mixed together, then you are having AB interaction. Now in AB interaction you are getting less vapor pressure. Please listen carefully. Obviously in A and B, when you are making a solution, the AB interaction you are getting less vapor pressure. That means one thing, that AB interaction is more. AB interaction is more. The force of attraction or the attractive force between A and B is more. That's why they are not that much going to the vapor phase. That's why they are not going to the vapor phase, because they are already attracted by each other. So they are not going to the vapor phase. As they are not going to the vapor phase, that's why negative deviation. And negative deviation means that I can say that vapor pressure decreases. Obviously from the graph I can say that vapor pressure is decreasing. But sir, what about boiling point? You know boiling point. What is the boiling point? Tell me what is boiling point. Boiling point is the temperature at which vapor pressure and atmospheric pressure is same, right? Now you see your vapor pressure, let me just change the color. Your vapor pressure is already decreased. Now to match atmospheric pressure is like this, your vapor pressure was like this previously. Now your vapor pressure already decreased. So that means you need more and more temperature to match this. You need more and more temperature to match the atmospheric pressure. That means that boiling point increases. Option number 4 will be your answer. From graph also you can say that previously said this was the graph and this was the atmospheric pressure. And this was the vapor pressure. Sir, vapor pressure decreased because negative deviation हुआ है, because it is a negative deviation. Sir, now vapor pressure is like this, and you see previously this vapor pressure was matching the atmospheric pressure at this temperature. Now your vapor pressure, as it decreased, it is matching your atmospheric pressure at this temperature, and you see this value already increased, and that is called del TB equal to TB dash minus TB, and this is from Raoult's law. If you are having a very good understanding about all this theoretical aspect, then only you can answer this question. Otherwise it might be a little difficult for you. It's an easy question, but yeah, you have to think about this question. Okay, I hope you understand this. If you are not, please let me know. I'll make a detailed video only about this question. Okay, so now let's go to the next thing. What is the next thing? Yes, this question is this question we have done several times. This is so easy. You see what you have to do. It is so easy because in this question what is happening, you see NaCl, H2SO4 and K2Cr2O7 product. Always when the reaction is like this, that potassium dichromate, this K2Cr2O7 is what? K2Cr2O7 is potassium dichromate. Potassium dichromate with NaCl and plus H2SO4. We have done so many times. This gives chromyl chloride. I am not writing the balanced equation. This gives chromyl chloride. That CrO2Cl2 is chromyl chloride, and this chromyl chloride is red in color. Red in color, red paper. I told you every time that from here you will get a question related to color. Chromyl chloride, it's a red in color, and this is your A, and in this if you put NaOH, from here you will get Na2CrO4, that will be green in color. Na2CrO4, that will be green in color. This is CrO4, means CrO4 2 minus actually. CrO4 2 minus actually. This will be green in color, not green, sorry, yeah, mistake, sorry, not green, you will get yellow in color, it will be yellow in color. Okay, so from here this red color is chromyl chloride and Na2CrO4 is yellow color. This has to be known by you. From here almost like more often than not you will get a question from here. Okay, so here your A is chromyl chloride, B is Na2CrO4. Now tell me in organic reaction, tell me an organic reaction where you have to use chromyl chloride as a reagent. Now tell me an organic reaction. Sir, it's very easy, it's Etard reaction. It's Etard reaction, sir, because in Etard reaction what happens, from CH3, if you want CH or benzaldehyde, you have to use CrO2Cl2 in CS2 medium. Several times these reactions we have done several times, right? Okay, now go to the next question. This question is a very easy question also, so you have to know that strong field, weak field, all these things, then it will be very easy for you. Okay, so what they are asking, sir, Fe F6 3 minus, Fe F6 3 minus, that means that here Fe is in +3 state. I hope you know all of this, how to calculate this. If you don't, then it will be a big problem. You please ask me, then I will tell you how I am getting Fe F6 3 minus from here, how I am writing that Fe is in +3 state. And sir, Fe +3 state means it will be a D5 system. It will be a D5 system, and sir, F minus is a weak field ligand. F minus is a weak field ligand. All the halogens are weak field ligand. Okay, sir. If weak field ligand, that means that no pairing will take place. No pairing will take place in 5. You are having 5 unpaired electron. 5 unpaired electron, n equal to 5, and your mu value will be root over n into n plus 2. That means root over 5 into 7. That means root over 35 Bohr magneton. You don't need to calculate all of this, just this n equal to 5 is needed and you can tell. Okay, sir, by the similar way please solve VH2O whole 6 2 plus, no problem. You see just give me a moment. VH2O whole 6 3 plus, sir, H2O is neutral, so vanadium is in +1 2 oxidation state, and vanadium +2 means that vanadium was 23, so 4s to 3d3, 2 electron gone, it's a D3 system, and said D3 system means I can say that 1 2 3 4 like that, and I am having n equal to 3. So previously your n equal to 5, now you got n equal to 3. Okay, sir, and then the last thing, FeH2O whole 6 2 plus. Sir, H2O is neutral, so Fe is in +2 state. That means it is 3d6 system, and 3d6 means that actually not 6 unpaired electron, actually we are having 4 unpaired electron, 1 2 3 4 5 and 6. That means that I am having this n equal to 4 unpaired electrons. So sir, maximum I am getting in here, followed by this will be in the second position and this will be in the third position. So if it is P, if this is Q, and if this is R, so I can say that P will be the highest, followed by R greater than Q, PRQ. PRQ. Sir, option 1 is matching very beautifully, and option number 1 will be my answer. These questions are very easy, like it is the easiest paper I saw in the recent past in JEE. This is the easiest paper, probably. Like there should be some arguments. I am already like I am appreciating the arguments that yes sir, how can you say this is so easy, because like this, like the questions are very straightforward. Like there is nothing in organic thing also, the questions are very straightforward. They have not asked anything that needs like brainstorming or something. Sir, electronic configuration of neodymium, how to do it, ND, how to do it. Sir, it's very easy. Sir, we will always think about xenon, the nearest inert gas configuration. We will always think about the nearest inert gas configuration. Sir, how to do it? Nearest inert gas configuration, xenon is 54. So xenon 54, I got it. Okay, after xenon, then electron will go to 6s2. Yes, electron will go to 6s2. After 6s, you are having 4f, and how many electron? You see 54 plus 2, 56 is done. You have to go to 60, so you have to add plus 4. That's it. Xenon 6s2 4f4. This you have to know. That will be your answer. It's so easy. But here there are something I want to tell you, that for lanthanum there is an anomaly, right? For lanthanum there is an exception, I can say. There is a exception. What is the exception, sir? Lanthanum is 50, lanthanide is 57. So xenon 4s2, 6s2. After that it should go to 4f, but no, it is not going. It is going to 5d1. Okay, 5d1. This is the exception. That also you have to know. But whatever they have asked is very straightforward. Very straightforward. No exception. Whatever they have asked is very straightforward. No exception. No exception. Okay, no exception. Okay sir, then how to do this question? This question is from class 11. This question is from class 11, acid base concept, right? Acid base concept chapter, this chapter, acid base concept. Sir, how to do this question? Na2CO3. This is from salt analysis, salt hydrolysis, not analysis, salt hydrolysis chapter. So I told you that NH4 whole 2 CO3, whenever a salt is given to you, try to analyze its mother part. Try to find out what is its mother part. Sir, mother part means from which acid and base you are getting this salt. Sir, it is very easy. Sir, from here I am getting NH4 plus and I am getting CO3 2 minus. That means that the base is NH4OH is the base, and CO3 2 minus, that means that H2CO3. That means that ammonium hydroxide is the base, and sir, carbonic acid, this is the acid. And sir, I know that this is also a weak acid and this is also a weak base, and if this is the factor, then we cannot say if the acid or base, like if the salt we are getting, if it is as a whole it's acidic or basic, because that depends upon the pKa and pKb value. From here we know that NH4OH is slightly more basic than H2CO3 as acid. Again I am telling, we know that NH4OH basic strength is more, again it is experimentally, we know NH4OH basic strength is more than H2CO3 acidic strength. Sir, how do you know? Yes, for that we need to know a equation. So the equation is pH is equal to 7 minus half pKa plus half pKb, and NH4OH, from here I will get pKb value, and from H2CO3 I will get pKa value, and here what happens, pkb value is greater than pka. That's what I am saying. And this is slightly, are you getting my point? Okay, so if this is the thing, sir, if this is the thing, then sir I can clearly say that 7 minus half pka and plus half pkb, if this is the case, then the value will be slightly greater than 7. This pH value will be slightly greater than 7. So it is, as a whole, the solution is slightly basic. As a whole, the solution will be slightly basic. Here I have written this thing wrong. pkb value, yes, so okay, just let me a moment, give me a moment. Okay, yes, these values I cannot compare without seeing the exact values. Okay, so what I can say is that NH4OH, its basic strength is more than that of the acidic strength of H2CO3. Okay, so here also the statement that is given, that is true, and statement 2 that is given, that is also true. Both the statement is true here. Okay, yes, acidic nature of salt H, WA and WB depend upon the Ka and Kb value. Here what I can say is that Kb value is greater than Ka value. That I can say. Kb value is greater than Ka value. That I can say. Okay. Okay, so now go to the next thing. Yeah, so number of electron present in a compound filled with filled subshell having n equal to 4. Okay, n equal to 4 and s equal to plus half. Sir, this question I can do within 10 seconds. Sir, how? Sir, n equal to 4 means maximum number of electron will be 2n square. 2n square means 2 into 4 square, that means 2 into 16, that means 32, and out of this 32, half will be having s equal to plus half and half will be having s equal to minus half. So half will be having s equal to plus half and half will be having s equal to minus half. That means that if there is total 32 electron, from here 16 electron will be like this, that is having s equal to plus half, and 16 electron will be like this, that is having s equal to minus half. So this is your answer. That means this 16 will be your answer. It's so easy. Okay, sir, then go for the next question. Yes, then for the next question we are having equation is given 2H2 plus H2 plus I2. Okay, experiment 1, 2, 3. What is given? HI, that means reactant. What is your reactant? That reactant concentrations are given. Okay, and rate is given. Okay, you have to find rate. No problem, sir. So I can write order. Sorry, we have to find order. So rate R equal to, I can write, sir, K HI to the power alpha. HI to the power alpha, where alpha is my order of the reaction. Alpha is the order of the reaction. Sir, yes, I got it. Then how to do it? You take any two experiment, which I should take. I am taking experiment number 2 and experiment number 3. Okay. And so experiment number 3, from there I am getting R3 and the value is given R3 equal to K HI to the power alpha and by R2 equal to K HI to the power alpha. Okay, and KK will get cancelled. Now I'll put the value of R3. So R3, what is the value given? 0.02. Okay, sir, 0.02. R2, what is the value given? 0.01. Okay, sir. Then HI, what is the value given? 1.2 into 10 to the power minus 2, and this is given 3 into 10 to the power minus 3. Okay, sir, if this is the case, then it will be better if I write this as 12 into 10 to the power minus 3 to the power alpha. This will get cancelled out, so this will get cancelled out. You will get 4 and you will get here 2. So you will get 2 equal to 4 to the power alpha. Am I getting this correct or not? Or let me just check. Oh my god, I have done a mistake here. I have put the values opposite. Okay, let me go to the next slide. let me go to the next slide. I have done the value opposite. Okay, so here I can write that R rate equal to K A to HI to the power alpha. Okay, then I am doing R3 by R2 equal to KK will get cancelled out. Okay, let's write KK and HI to the power alpha by HI to the power alpha. This will get cancelled. So R3 value is 1.2 into 10 to the power minus 2 and this value is 3 into 10 to the power minus 3. If this is the case, what I will do, I'll put this as 12 into 10 to the power minus 3 and I will cancel out this. Okay, this is 0.2, this is 0.1 to the power alpha, so this will be 2, this will be 4, 4 equal to 2 to the power alpha, 2 to the power 2 equal to 2 to the power alpha, and from here by comparison I can say alpha is 2. Alpha is 2, that means your answer will be 2. 2 will be your answer. It's the second order. It's the second order. Okay, so easy. Then sir, go for the next molecule. Then next question. Now this question I like a little because this question is totally about unit conversion. Like if you know the formula, but if you don't know about unit conversion, it's about unit conversion. If you know the formula, but if you don't know about unit conversion, you cannot do this question. So how to do this? So 3 moles of an ideal gas at 300 K expand isothermally. Okay sir, isothermal process is given. Isothermal process, ideal gas is given. Yes sir, isothermal process and ideal gas is given. That means delta equal to 0 and I can write as delta U is a function of temperature also. So we can write del U is also equal to 0. So from first law, we can write first law of thermodynamics obviously. From first law of thermodynamics obviously we can write that delta U equal to Q plus W and del U is 0. Why? Because it's a isothermal process equal to Q plus W and Q equal to I can write minus W. So obviously I have to find the amount of heat transfer I have to find. That means I have to find Q and Q is minus W, that I know. Now I have to calculate W. So W is equal to I can write minus P external dV, or we can write minus P external V2 minus V1, where V2 is the final and V1 is the initial. So P external is given. Yes, P external is given. It's 80 kilopascal. So 80 kilopascal is given. And sir, just check that heat they want in joule unit. Okay, heat they want in joule unit. That means they want in SI unit. They want this in SI unit. Okay, okay sir, kilopascal I got. And V2 is given 45 minus 30, but that is also given in dm3. Sir, in SI unit pressure should be in Pascal. Pressure should be in Pascal unit. And sir, volume should be in meter cube unit. Volume should be in meter cube unit. So now it's your duty to change it, to change the unit. Sir, it's so easy. Minus 80 from kilopascal. If you want to do Pascal, it's very easy. You have to just multiply 1000. And sir, 45 minus 30 also, sir, I can write that it will be 15 only. It will be 15 only. And sir, dm3, sir, we know that 1 meter is equal to 10 dm. 1 meter is equal to 10 decimeter. That means sir, 1 decimeter is equal to 10 to the power minus 1 meter, and 1 dm cube is equal to 10 to the power minus 3 meter cube. Okay sir, I understand now. In dm cube part I want to write 10 to the power minus 3. Now this pressure is in Pascal and this is also in meter cube. This is also in meter cube. Okay sir, then this will get cancelled out. I am happy. Minus 1200 Pascal and meter cube. From here I can write it as joule. And this is your W value. This is your W value. That W equal to you got as minus 1200 joule. So Q equal to will be 1200 joule. That will be your answer. Q equal to 1200 joule will be your answer. By this way you have to do. So for this your answer will be plus 1200 joule. Okay. This question is also quite good. I like this question. So this question we can do by equivalent weight. Okay, it will be better to do equivalent weight. And I know, I hope that from Faraday's law, when I taught you Faraday's law, I told you that one equivalent of any substance, that equivalent to, like, that is equal to 1 Faraday electricity. Just give me a moment. One equivalent of any substance, that means 1 Faraday electricity. You can use this formula, or you can use 1 mole electron, that is equivalent to 1 Faraday electricity. Anything you want, which one is best suitable for you, you can use. One equivalent of any substance is equal to 1 Faraday electricity, or 1 mole electron that carries 1 Faraday electricity. Anything you want. Sir, this thing is a little difficult for me, that 5610 ml O2. No problem. You know this thing, na? That 1 mole O2, that means what? 32 gram O2. That means what? That means 22400 ml. 22400 ml. Got it? Now you are having what do I say, 5600 ml. That means just 1/4. That means you are having 8 gram oxygen. 8 gram oxygen. And I hope you know oxygen equivalent weight is 8. Sir, you have taught us this? Yeah, I told you this like this way. Just give me a moment. So I have told you like this way, that hydrogen, oxygen and chlorine, their equivalent weight is standard. Hydrogen, the value is 1.008. You can take this as 1 gram. Oxygen, it is 8 gram. And for chlorine, it is 35.5 gram. Now you got that 5600 ml oxygen means actually 8 gram oxygen. That means actually 1 equivalent oxygen. And sir, that means you are saying 1 Faraday electricity, right? Yes, because 1 equivalent of any substance means 1 Faraday electricity. That means from here I can directly say that 5600 ml O2, 8 gram O2, 1 equivalent O2, 1 Faraday electricity. That means, sir, by saying this, they are ultimately saying that 1 Faraday electricity is passed. 1 Faraday electricity is passed. Okay, sir, how much silver will be displaced by this? Okay, so how much silver? So silver is Ag plus, right? So its equivalent weight equal to what? Atomic weight by valency factor. Atomic weight is 108. Valency factor is +1. That means silver equivalent weight is 108 gram. And what I told you, 1 gram of 1 equivalent of any substance is 1 Faraday. That means 1 Faraday of any electricity means 1 equivalent of any substance. And for Ag, 1 equivalent means 108 gram. And that is your answer. Got it? So what I have done? Very easy. From 5600 ml oxygen, I calculated that this is actually 1 equivalent oxygen. And for 1 equivalent oxygen, that means 1 Faraday electricity. And 1 Faraday electricity means also 1 equivalent of Ag also. 1 equivalent of any substance. 1 Faraday electricity means 1 Faraday of any substance. Now 1 equivalent of Ag also you will get. And for Ag, 1 equivalent means its atomic mass by valency factor Ag is +1. So that means 108 gram. It's so easy. So easy. Got it or not? So your answer will be 108 here. What will be your answer? Your answer will be 108 here. Got it? Okay. Now moving to the next question. Said this is probably the easiest of the lot. Said sulfur we have to do. Okay, hydrogen, 2 hydrogen, each of them is +1. Sulfur is 2x. 7 into -2 equal to 0. So 2 plus 2x minus 14 is equal to 0. So 2x equal to 12, x equal to +6. H2SO3. So 2 into +1 plus sulfur is x plus 3 into -2 equal to 0. So 2 plus x minus 6 equal to 0, x equal to plus 4. So sir, plus 4 oxidation state is option number 2. It's so easy, right? We don't have to waste time here. Then sir, which of them does not show variable oxidation state? This is again from general introduction of general introduction, or we can say general discussion of p block element. Okay, p block element, and this is from group 17. Actually this is from group 17, and in group 17 what are the things you are having? Fluorine, chlorine, bromine, iodine. Among them, who is more electronegative? Fluorine is most electronegative. So for fluorine, as it is most electronegative, it is always and always it is in +1 state. Oh my god, sorry. As it is more electronegative, it is always and always it is in -1 state. It cannot show variable oxidation state. For sir, I know that all of them, that fluorine is -1, I know, but chlorine minus, bromine minus, I minus also I have heard. Yes, all of them can show -1. That is very good. But fluorine can show -1 only, no other thing. Sir, chlorine can show any other thing? Yes, it can show +1, +3, +5. All of them can show +1, +3, +1, +3, +5, like that. Sir, give us example. You take example ClF3. You take example HClO4, HClO3, HClO2, HClO. You take your example. This is +7 state, this is +5 state, this is +3 state, this is +1. So all the other halogen, they can show variable oxidation state. They can show variable oxidation state. But fluorine, as it is the most electronegative, however you combine it with any other atom, as fluorine is most electronegative, it will always take the -1 charge. It will always take the -1 charge. So fluorine will be your answer here. Okay, now next question, what they are asking, statement 1, 4f and 5f series are written separately in the periodic table in order to preserve principle of classification. Yes, so in the periodic table, if you see, you are having group 1 and group 2. This is called S block. This is called S block. Then from here you are having group 13 to 18. 13 to 18 you are having, that is called P block. That is called P block. In the middle part you are having D block. In the middle part you are having D block. And in the below part you are having two groups. The first one is 4F, second one is 5F. First one is lanthanide series and the second one is actinide series. Yes sir, so the statement 1 is true. S block elements can be found in earth in pure form. No, this is not true. As S block elements are having metallic character, S block elements are having metallic character, they are electropositive. They are electropositive, and in nature, in the air, what you are having oxygen, you are having sulfur, you are having nitrogen, right? That okay, so they make oxide, sulfide, nitride, chloride, like that. Okay, you cannot make them, you cannot get them in free state. You cannot. Whom you can get free state? Ag, pt. It's not Ag, actually Au I should write. Au, pt, this type of thing you can get in free state, but no, S block element, no. So statement 1 is correct, but statement 2 is not. Okay. Okay. Now here, sir, which of the following is most acidic? I told you many times that whenever acidity question will come, acidity proportional to stability of conjugate base. So sir, conjugate base means what? You are trying to say conjugate base. Conjugate base means from here if you take the hydrogen, from here if you take the hydrogen, and from here if you take the hydrogen, take the hydrogen out, take the hydrogen out. Take the hydrogen out. If you are taking the hydrogen out from the first step, from the first molecule, I guess you are getting this kind of thing. you are getting this kind of thing. From 1, from the second you are getting this kind of thing, from the third you are getting this kind of thing, and from the fourth you are getting this kind of thing. Now tell me which is the most stable carbon ion. Which is the most stable carbon ion? Sir, this can do resonance like this, so it will be stable. This can do resonance like this, it will be stable. This can do resonance like this will be stable. And sir, this can do resonance in with both the carbonyl group. So 3 is the most stable conjugate base, as 3 is giving the most stable carbon conjugate base. Why? Because the carbon ion can involve itself in resonance with both the side, with both the carbonyl group. So as it is giving the most stable carbon ion, so its acidity is more. 3 will be my answer. It's so easy, right? It's so easy. Sir, this question is another beautiful question. How to do this question, sir? Sir, first of all we have to understand what is Bronsted base, right? So Bronsted base is the atom or the species that can take H plus, So who can take H plus, sir? For whom the lone pair is available to donate. The lone pair is available to donate. What is the meaning of this? Suppose ammonia, nitrogen lone pair, it has to donate to H plus, then it can take H plus, right? Then only it can take your H plus, then only it can take your H plus. So NH4 plus, then only it can make, then only it can show its Bronsted basicity. Sir, all are having nitrogen, so what is the problem? All are having nitrogen. So the problem is that here in the first molecule the nitrogen lone pair is engaged in resonance, and as it is doing resonance the lone pair is no longer available. And sir, this molecule name is aniline. We have done this so many times. This is called pyrrole, and pyrrole and period in chemistry we have done it many times. Said this nitrogen lone pair is also involved in resonance. Not only in resonance, this lone pair is engaged to satisfy its aromaticity, right? Aromaticity. I have discussed detail in the batch about this, right? Sir, what about 4? Sir, from 4 also I can say that this nitrogen lone pair is engaged in resonance. Not like this, not at this extent, but yes, this is also involved. But sir, from 3 what you are getting, it is having no resonance involvement, and this ring bond plus effect lone pair is totally available. It can donate to a H plus, and it can show the basicity. Option number 3 will be your answer. So easy, right? Okay, sir. So there is a question about this one also. I don't have to explain this thing. You already know how to do this. SN1 means racemization. SN1 means racemization. Just one thing I can say is that it is not a total 100%. No, not 100% racemization, not 100%, but yes, almost racemization we can say. Almost racemization. Racemization means what? Inversion is also going on and retention is also going on. And in SN2 what happens? SN2 is complete inversion. So if this is your thing, SN1 racemization, SN2 inversion, option number 2 will be your answer. It's so easy, right? So easy. Okay, sir. Here this question is actually good. This question is very easy, but the question is good. Maximum enol content. You don't have to look for any other thing. You don't have to look, because you see your first molecule is looking like this. And I told you, whenever there is a question about enol content, what you have to do, you have to search for alpha hydrogen. So alpha hydrogen means this carbon is keto group, and this is your alpha carbon. You have hydrogen here. This is your functional keto group. This is your alpha carbon. You are having hydrogen here. This is your alpha keto group. It is your alpha carbon, and this is having your hydrogen. Now if you do tautomerism, see, do tautomerism, I don't know in the exam hall it is clicked to you or not, but if you do tautomerism, actually you are getting a benzene moiety. Actually you are getting a benzene ring. Actually you see, actually you are getting a benzene ring. That means by this tautomerism, this is a tautomerism step you have done, and in this tautomerism what you have achieved? You have achieved aromaticity. You have achieved aromaticity. You have achieved 6 pi electron. You have satisfied 4n plus 2 pi electron rule, right, where n equal to 1. So you have achieved aromaticity, and aromatic benzene ring is always stable. So you don't have to look for any other thing. Option number 1 will be your beautiful and correct answer. Got it? Got it? Then what about this thing? So this question is also very easy. Which of the acidic strengths? Sir, acidic strength, again as you told sir, we have done the same thing. Acidity proportional to stability of conjugate base. Any question about acidity, just use this, stability of conjugate base. That stability of conjugate base means, so from the first, if I make the conjugate base, it will be looking like this. It will be looking like this. Yes. From the second, if I make the conjugate base, it will be looking like this. It will be looking like this. From the third, if I make, it will be a normal phenoxide ion. From the fourth, if I make, it will be like this. And from the fifth, if I make, sir, it will be like this. Sir, I know what you are trying to say is that this is a very good resonance, a high extent resonance, because the NO2 group is actually by its minus I and minus R effect helping to stabilize the negative charge. You know these things. Whoever has learned these things from me, you know these things. Okay, this is going here, so this is going here, this is going here, this thing is there. Also this negative charge, this, what do I say, this NO2 group is also doing the same thing. So both the NO2 group are stabilizing. So sir, if from this one, if it is 2, 3, 4, 5, already I can say, sir, already I can say, let me just change the color. Sir, already I can say that 2 will be most stable followed by 1. Okay. Then sir, what happened to 3? So 3 is stable, no problem. In benzene this is having resonance, but there is no other extra stability. There is no other extra stability. Okay sir, so 3 को इधर रख दीजिए. अभी 5th को देखते हैं. 5th क्या है देखते हैं. Sir, 5th is also trying to do the resonance, but sir, this OCH3 group is not helping. This group is actually not helping because this is doing a opposite resonance. This is showing its plus R effect. That means that this R group, this plus R effect, this OCH3 group is not helping in stabilizing the negative charge. This is destabilizing. But sir, this is destabilizing, I understand, this is destabilizing. But sir, this phenoxide like benzene ring resonance is happening. This benzene ring resonance is happening, but with that, whatever is happening in 3, that is also happening in 4, 5. Whatever is happening in 3, that is also happening in 5. But sir, in 5, this OCH3 group is not stabilizing, it's a destabilizing. Okay sir, I understand. So sir, 5 को इधर रख दीजिए. But sir, 4 का क्या? 4 में तो कुछ resonance कुछ नहीं हो रहा है. Yes, 4 is not having any resonance. 4 is not having any resonance. So that will be in last. That will be at the last position. Now you can say, sir, between 4 and 5, why you choose 4 at last? Because 4 there is no resonance. In 4 there is no resonance. In 5 there is resonance. With the benzene ring, there is resonance. Only the factor is that the OCH3 group is not helping. That is the thing. So 2, 1, 3, 5, 4. 2, 1, 3, 5, 4 Yes sir, option number 1 is matching very beautifully, and that will be your answer. Option number 1 is matching very beautifully, and that will be your answer. Okay sir, then go for the next question. Okay, the next question is like this. So this molecule said this is super easy, this is super easy. The thing is said where you are getting your where you can give lowest locant number to your substituent, that you have to do. Said if I take this carbon as 1, then I can write 1 comma 1. At one position I am getting 2 substituents, that will be my carbon 2 3 4 5 6. But said at one position I am getting methyl group that starts with M, and at 3 positions there I am getting ethyl group, and ethyl group starts with E. So while naming alphabetical order I should maintain, so alphabetical order E comes first, so I have to start with 3 ethyl, 1 comma 1 dimethyl cyclohexane. That means that it's a very easy. Option number 2 is my answer. Option number 2 is my answer. Okay, now come here. Cyclohexene is classified as, cyclohexene means this one sir, cyclohexene. Now this one, you see, this is a cyclic structure. This is a cyclic structure. Is this a benzene ring? Is this a benzene ring? No sir, it is not a benzene ring. So it is not benzenoid. It is not benzenoid. It is not benzenoid. Is it aromatic? Is it aromatic? No sir, it is not aromatic, because aromatic it should have conjugation, planarity, all this. No, it is not. Is it acyclic? No sir, it is not acyclic also. It is cyclic. It is cyclic and it is aliphatic. Okay, so it is aliphatic and it is cyclic. When this is a combination, that is called alicyclic. This is called alicyclic. This is probably the easiest question from this organic part. Alicyclic will be your answer. Okay. Okay sir, then this question said this is easy, very easy. CCl4 looks like this. It is ideal tetrahedral. Sir, if it is ideal tetrahedral sp3, then all the dipole moment will be cancelled out, mu equal to 0. Sir, CH2 double bond CH2 is a planar structure, and it is a symmetrical structure, mu equal to 0 ho gaya. Sir, CO2, you have told us whenever we are doing hybridization that it is sp means linear structure, and this dipole moment and this dipole moment cancel out each other, so mu equal to 0. Only in case of this molecule the dipole moments are not 0. It is totally one dipole moment. I am getting mu not equal to 0, and sorry, I should write another Cl here. Yes, and this bond also like this. So it will not cancel out each other. Why? It will not cancel out because all the bonds are not identical. So like all the atoms are not identical. So mu not equal to 0. This one is mu equal to 0. So ye ho gaya non-polar, ye ho gaya non-polar, ye ho gaya non-polar, or the ultimate one, this one ho gaya polar. So sir, it is polar means this will be your answer. So easy. Okay sir, then go for this question. Okay, so this question is they are asking for न्यूक्लियोटाइड. सर न्यूक्लियोटाइड कैसे देखते हैं? न्यूक्लियोटाइड में एक तो होता है एक सुगर ग्रुप होता है, पेंटोज सुगर, राइट? ओके, आई डोंट वांट टू राइट हियर बिकॉज यस, एक तो होता है ये पेंटोज शुगर, Now number this carbon 1, 2, 3, 4. Here you are having a CH2OH group. This carbon is fifth carbon. Now with the carbon number 1 you are having a nitrogen base. ये कुछ भी हो सकता है, ये एडेनिन हो सकता है, गुआनिन हो सकता है, साइटोसिन हो सकता है, यूरासिल हो सकता है, कुछ भी हो सकता है. एडेनिन नाइट्रोजन बेस हो गया कार्बन नंबर 1 के साथ. With carbon number 3 you are having this kind of group. this kind of group, and with that the other nucleotide is bonded. So you see ये हो गया पेंटोज शुगर एंड यहाँ पे हो गया ये जो phosphate group, this phosphate group is actually binding the other molecule. Okay, the other molecule here again a nitrogen base. So the question is regarding this linkage. You see the first one, it is a nucleotide and this is a nucleotide. These two nucleotide is binded by this group. So this group is called phosphodiester linkage. And whoever is preparing for, again on any other example, disulfide linkage we can get in secondary structure. Let me just change the color. Disulfide linkage we can get in secondary structure of protein. That means alpha helix, beta sheet, there we will get disulfide. Glycosidic linkage we will get in disaccharides. So when two monosaccharide units are joined, that is called disaccharides. And peptide linkage we will get between two amino acids. Is joined by peptide linkage to make the primary structure of protein. Glycosidic linkage we will get in disaccharide. Disaccharide means, suppose you are having sucrose. In sucrose is what? Glucose plus fructose, right? And glucose plus fructose, in between that you are having glycosidic linkage. And in amino acids, in nucleic acid, what you are having? Phosphodiester linkage. Got it? Okay. So this question is super easy. This nitrogen is having lone pair, so it is donating electron. Whoever is having, you see, whoever is having plus R or plus I effect, they are activating group. And activating group means they are orthopara directing group. Whoever is having plus R or plus I effect, that means we can say electron donating group. They are activating group, they are orthopara directing. Whoever is having minus R or minus I effect, that means we can say electron withdrawing group. Electron withdrawing group means they are deactivating group. And deactivating group means they are meta directing group. And meta directing group means, okay, they are deactivating. Okay, but here only one exception is there. What is the exception? The exception is halogen. Halogens are what? Halogens are neatly deactivating but orthopara directing. So you see, I have done a 2 hours lecture on this. Like in my classes, I have done a 2 hours lectures totally on this only, when I taught you that activating group orthopara directing, deactivating group meta directing. Only and only halogens deactivating but orthopara directing. Okay, sir. Then go for the question. So what is in the question? What is given? Let's see. Sir, this is nitrogen lone pair is giving plus R orthopara, that activating orthopara. Sir, they are asking for meta. That will not be the answer. OH oxygen lone pair orthopara, not be my answer. Now you see COR means what? It should look like this, right? C double bond OR. Now C double bond OR means it will take electron. It's an electron withdrawing group. So electron withdrawing group means it is meta directing. Now you see halogen aa gaya. Halogen is the exception. Deactivating but orthopara. They are asking for metas and not be my answer. COOH, said COOH, I know. COOH, I know, sir. C double bond OOH. That means that it will withdraw electron. Withdraws electrons means that meta. That means my answer. Sir, OCA is 3, oxygen lone pair, it donates. Sir, it is orthopara, not my answer. NO2 is the most deactivating. NO2 is the most deactivating cell. Deactivating means orthopara. It is my answer. CN, that CN also, if you write CN, C triple bond N, said this is also electron withdrawing. That is my answer. CH3 is plus I effect. That means activating, not my answer. So this is my answer. COR, COOH, NO2 and CN. So 4 molecule. I get 4 molecule as my answer. 4 molecule as my answer. It's so easy, right? Okay, sir, this one I can do. This is very easy. This is what I will do is I will do Markovnikov, right? I will do HBr and peroxide is given. Sir, HBr peroxide is given. That means Br will go to the carbon that can form what do I say, that can form less stable carbocation like that. Okay, so Br will, if I number this as 1 and if I number this as 2, I hope you know this. If you don't, then you please revert back to me that why I am doing so. Br will go to carbon number 1. Br will go to carbon number 1. Sir, if this is the case, then sir Br will go to here, you are saying, right? And automatically this hydrogen will go here. Okay, sir, if this is the case, then they are asking how many products including stereoisomers. Sir, the question is about stereochemistry, so we have to find chiral center. Sir, this center is chiral center, right? Because bromine, methyl, this group and a hydrogen. Sir, ये center तो chiral center हो गया. All the 4 are different. This center, this group different, this group different, this is a methyl and this is a hydrogen. Sir, ये center भी chiral center हो गया. So 2 chiral center. So how many stereoisomers? Sir, formula I know, 2 to the power n, where n is the number of chiral center. N is the number of chiral center. So 2 to the power 2, that means 4 will be my answer. 4 will be my answer. So easy, right? 4 will be my answer. Sir, here what happens here? Let me just go to here. So this question also, which of the following is correct with enzyme? This is a question regarding enzyme. And the first thing that comes to my mind is the sucrose inverted glucose plus. Obviously, because sucrose, if you know, sucrose is actually dextrorotatory. Dextrorotatory. It is having an optical rotation value in positive. Okay. From sucrose, if you get glucose, if you do hydrolysis, you will get glucose plus fructose. This glucose is also dextrorotatory. Like positively, it rotates the plane polarized light in the positive direction, but fructose, it rotates in the negative direction. And the thing is the modulus value. The modulus value, if you take the modulus value, it was observed that the modulus value of the negative charge, negative value is more. That means ultimately your solution previously was positive, like plane polarized to the right hand side. Now as a whole, as your negative modulus value is more, it becomes on the left hand side. It rotating the plane polarized on the left hand side. That means inversion. For that, what is the enzyme? Invertage. That will be your answer. It's so easy. You see, starch to maltose, pepsin, not a possible way, because pepsin is for protein. So all others are not correct. Sucrose to glucose plus fructose, this is called inversion of sugar. This is very important for your board exam also. I told you, inversion of sugar, and for that the enzyme is invertage. So this will be your answer. Okay. And another question I got is probably this question. Ethanol shows turbidity with Lucas reagent. Said, what is Lucas reagent? Lucas reagent is anhydrous ZnCl2 plus concentrated HCl. This is your Lucas reagent. Several times we have discussed this, and I told you that if there is a 1 degree alcohol, if there is a 2 degree alcohol, if there is a 3 degree alcohol with Lucas test, what happens? if you give Lucas reagent, in 3-degree carbo alcohol, from there all the reactions are SN1 mechanism. Okay, Lucas reagent reaction is SN1. Why and all this I have already discussed in the classes. SN1 mechanism. So SN1 mechanism means I will get 3-degree carbocation, and 3-degree carbocation is most stable. It is most stable. That means that I will get immediate turbidity. Immediate turbidity I will get. Okay, sir, I understand. From here I will get 2-degree carbocation. And sir, 2-degree carbocation, I can write it's moderately stable. I can write this as moderately stable. And sir, moderately stable means here also I'll get turbidity, but I'll get turbidity after 5 minutes. And for 1-degree alcohol, I'll not get turbidity, or I'll get turbidity after so long. After so long. Why? Because I'll get 1-degree carbocation, and that is not stable at all. And sir, what is this question? This question is about ethanol. Sir, ethanol means CH3CH2OH. Okay, sir, that's why the carbon having OH group is directly bonded to one carbon, so that is 1-degree alcohol. And sir, from here if you do Lucas reagent, you will get CH3CH2 plus, 1-degree carbocation, and that is not stable. So this reaction is not possible unless and until you do heating. Then ultimately you will get CH3CH2Cl, and you can generate turbidity. But for that, the condition is it will not go by its own, because 1-degree carbocation is not so stable. You have to use external force. External force means you have to use heating. So here your answer will be upon heating it can show turbidity, otherwise not. So by this way all the questions have been discussed. You see all the questions. I hope these are the questions you got in your exam. If there is any question that I missed, please let me know. I'll give you an explanation about this also. And I know I went a bit fast here because so many questions I have to discuss. If you are having any problem understanding any of these, please let me know, okay, in the chat box, or like my WhatsApp, Telegram is always open, so you can ask me. Okay, I will make a detailed video on this. Okay, so with that, thank you so much. I will come as soon as possible with the other shift questions also. Okay, I have to gather the questions from my students and then I can make the video of it. Okay, so thank you so much, and like all the best for your exam. If you are having any problem regarding these shifts, this JEE attempt, don't worry, you are having another attempt in April and you can do well. Just follow the path, just follow the routine, just be with me, you can do wonder. Okay, so with that, today it's bye bye. Okay, thank you. Yes.